Okay, this is our study guide on Unit 7, which deals with probability. So I'm going to try to go through rather quickly. There are 29 problems on this study guide, as you know. Some of them have parts A, B, C, D, E, F, G. Um, the test has 22 questions on it, 15 of which are exactly like the problems on the study guide, but I changed the numbers. 7 of which have new words and new numbers, but can be related to something on the study guide or something from your homework. Or classwork. And you do get 2 freebies. Each blank will be 5 points. And the problems will all be scrambled. So I can guarantee you the first problem on your test is not a frequency table as we have here. So we have our frequency table. Seniors and juniors at Wahlberg High School were given the choice between a picnic in the spring or winter formal dance. The table shows the distribution of the students' preferences by class. If a student is randomly selected from juniors and seniors, what is the probability the student is a senior? So, um, let's go with that. Probability the student is a senior. Do you have to put the notation on there? No, but it helps me know what your thought process is, and if I'm going to give you partial credit, then I would suggest you do that. Okay, probability of a senior is the total of 750 students, and out of 750 students, how many of those are seniors? That would be 400. And so you reduce that, so that would be 8 over 15. Basically, this would go in the workspace. I've spaced the problems out more on the test, so you put that in the workspace, and this will go in your answer blank. I will accept a simplified fraction, a decimal to at least 3 places, or a percent. And that percent should not be a whole percent unless your answer is a whole percent. Okay, so your percent should go out. If you have 3 decimal places, then your percent should go out to the tenths. All right, moving along. Probability that is a junior given the student chose the picnic. So a junior given the student chose the picnic. Okay, this part, and because I have the word given in here, it changes my denominator. So my denominator is that total number that wanted the picnic, and that would be 385. And of those, and when you have a given also, that means now I'm only looking at these numbers. So out of a total of 385, how many of them are juniors? And that would be 120. So again, simplify that. If you don't know how to simplify that on your calculator, most calculators have a fraction button, unless you're using an 83 or 84. But if you use your fraction button and put 120 fraction bar 385, it should spit that back out at you. But of course, if it doesn't, you can put in the decimal that it gives you. Okay? Moving along. Probability that is a senior and chose the formal dance. So I have some room here. So I'm going to say probability of a senior and chose the formal dance. So when I have an and that chart, then I know, and this is again what would be in your workspace. It's an and problem. It's not a given problem. So my total is still the original total from my chart of 750. How many people? How many people are seniors and chose the formal dance? That would be 235. So I have 235 over 750, and when I put that in my calculator, it reduces to 47 over 150. Kind of hard to read. Let me fix that. Okay, moving along. Mm. Probability that the student is a junior or chose the formal dance. So that would be probability is a junior or chose the formal dance. And if it's or, that's when you're doing the adding, okay? And this one is when you have the new denominator. That's what we talked about whenever when we've done those problems. Okay? So it's not a new denominator, so I'm still going to have 750 on the bottom. But I've got to go find all those people that are juniors or chose the formal dance. So here's a junior and a junior and a formal dance. So if I add up all 3 of those numbers, I'll go ahead and write that out. So that would be 120 plus 230 plus 235. And that, of course, is 585 over 750. which is a fraction that reduce is 14 out of 15. Um, the other way that you can do it, if you wanted to choose the totals, okay, you could do the totals of the juniors, which would be 350, plus the totals of formal dance, which is 465, and then subtract out the one that's and. Okay, so that would be minus 230. You get the same thing. Okay? All right, moving on to number 2. Come on. Oops, there it is right there. The Yeti problem. Many people use Yeti products to keep their drinks hot or cold. One of the most popular items is the tumbler, which comes in two sizes, 20 ounces or 30 ounce. A survey was taken at the local mall. Here are some of the results. And so we got some information. And if we have just two choices here or not, I think it's going to be easiest to put this into a tree diagram. So I'm going to start off with each one has a 20 ounce or 30 ounce cup. So I have 20 ounce. That doesn't look like 20. Let's try that again. 20 ounce or 30 ounce cup. And then from there, each one will either be hot or cold. That's how they use the cup, hot or cold. Okay. Now, when you go fill these in, okay, 75% of the people who owned a tumbler had a 30-ounce cup. So that means this branch is 75%. And we know that if this is 75, then the other way is going to be 1 minus 0.75 or 100 minus 75. Either way, this is 0.25. Okay? And then, so that took care of that first one because it tells us the rest owned it. Of the people who owned the 20-ounce tumbler, 35% used it to keep their drinks hot. So we have 35. Whoops, that doesn't say 35. Go back. 35% is 0.35, and the rest are going to keep it cold, so that's 0.65. Again, 1 minus 0.35 is 0.65. And then 60% of the 30-ounce cup owners keep their drink cold. So of the 30-ounce cups owners, 60% keep it cold. So this is 0.6, and this is 1 minus 0.6, which is 0.4. Okay, so you have your tree diagram, and the thing about this, when you do your tree diagram, that's enough to show me the work that you can answer the questions. And the only one that you multiply to get an answer is if you are asking an and question. This is an answer to a given problem. Given you bought a 20-ounce cup, what's the probability you're going to keep your drinks hot? Okay, so, well, that was interesting. What is the probability that it keeps a drink hot given that it's a 30-ounce cup? So this would be the probability that it's hot given you have a 30-ounce cup. Okay, so you're going to go on the branch with 30 and go to the hot, and it's 0.4, so you can write 0.4 or you can write 40%. I'll put that different color. No, not. We'll keep it there. Okay. Um, if percents make it easier for you to understand the problem, I don't have a problem. However you want to write that, okay? So this, of course, is zero point 0.4, and we wrote it as a percent. What's the probability that a randomly selected cup is 20 ounces and keeps a drink cold? Okay, this is an and if you have an and, then you're going to multiply those branches. What's the probability that is 20 ounces and cold? So that's what I'm doing. Probability of 20 and cold. So you go find 20 and cold. That's this number and that number because that's that branch, and you're going to multiply them together. So it's 0.25 times 0.65, and that gives you 0.1625. So you can leave it as a decimal, or you can give me 16.25%, or you can give me 16.3%, but don't give me 16%, please. Okay. Which one is more likely to happen? A randomly selected person owns a 20-ounce cup and uses it to keep a drink hot, or a randomly selected person owns a 30-ounce cup and uses it to keep it cold. Again, both of these are and, so I'm going to write probability of 20 and hot, or the probability of 30 and cold. So 20 and hot. 20 and hot is 0.25 times 0.35. And that gives me 0.0875. 30 and cold is going to be 0.75 and 0.6, which is 0.45. So which one is more likely to happen? The one that has the higher percentage. So I'm going to say a 30-ounce cup and cold. Okay? Alrighty. Continuing, what is the probability the randomly selected person is someone who keeps their drink cold? So this one's a little different. And when you do, when you do your tree diagram, if you're looking for someone who keeps their drink cold, that's at the end of the branch. So you got to add up this branch and that branch. Okay, 0.225 times 0.65 we did right here. So that is 0.1625. And then the other one is 0.75 times 0.6, which we did right here, and that's 0.45. So when you add those two together, you're going to get 0.6125. So you could answer 61.25%. Or you can keep the decimal, as we keep saying. Okay? All right. On to Bubbles and Buddy in Clown School. I'm not going to read that because I hope you've already read it. But we do get down here. There are only 3 levels of clown. If you notice, there's no numbers in here, so you have to use the information to actually fill in the numbers. There are only 3 levels to clown school. The beginners make up 45% of the school. That's that number right there. The intermediates make up 30%, and the advanced make up the remainder. Okay? The poll shows that a recent poll of clown schools shows that among the beginner clowns, okay, so in this group right here, Buddy is widely popular with 60%. So Buddy has 60% of the vote, and that makes Bubbles have 40% of the vote. So of the total beginners, 60% of 90, that of course is 0.6 times 9, and that's going to be 54. 40% of 90 is going to be 0.36. 36. So 36 plus 54 will equal 90. Okay, go to the next one. Let's see what else we got. So the poll also shows that Bubbles will lead the advanced with 80%. So advanced Bubbles has 80%. That of course makes Buddy to have 20%. So 80% of 50, or 0.8 times 50, is going to be 40, which makes the other 10 that are left, because 50 minus 40 is 10. And the last one, let's see what it says. Among the intermediate clowns, Bubbles polled at receiving 35% of the vote. So for intermediate, Bubbles has 35%. Again, that makes this guy have 65%. But when I find 35% of 60, which is 0.35 times 60, then this will be 21. And what's left will be here, which is 39. So then you add these up to find out the total that voted for Bubbles, or prefer Bubbles, which is 97. And add these up and you find out that the total for Buddy is 103. Now, based on the poll, if a clown is selected at random, what is the probability the clown is an intermediate? Okay, so that means I am taking a total of 60. I don't really have room to write my little P notation, so we're going to go with this time, but I would, like I said, would appreciate if you put it on the test. 60 are intermediate out of a total of 200, and when you simplify that, you will get 3 out of 10. Okay, acceptable answer. Is a beginner voting for Bubbles? So that would be a beginner and Bubbles. Beginner and Bubbles is 36. I'm going to write it over here. 36 over 200, which is 9 out of 50. Does it look like a 9? 9 out of 50. Okay. And then we have, based on your answer for B, how many clowns were intermediate and voting for Bubbles given that there were 400 clowns at the school? So, how many clowns were intermediate and voting for Bubbles? Okay, so we have, and you don't want to look at these percentages anymore. That's how we just filled out the first part. Okay, so intermediate and voting for bubbles is 21. So you got 21 out of 200, and you can find that percent and then multiply it by 400, or you can just set up a proportion and say if 21 out of 200, then how many out of 400? And most people see that's just times 2, so that's going to be 42 clowns. Okay, and I still have 400 students. How many students were advanced and voting for bubbles? So in this one, advanced and voting for bubbles is 40. Okay, so 40 out of 200 is our original survey problem, and I have 400 students in the school, so how many would I have here? And that, of course, would be 80. So I'm going to put 80 students. Anytime your answer is more than one, you should have a label with it, okay? Because that means that it was not a percent problem, a probability problem. If the poll is representative of the actual vote, who will be the clown favorite at graduation? We can clearly see that Buddy has more votes, so that answer would be Buddy. All right, continuing on to number 4. Create a tree diagram and give the sample space for spinning the spinner 2 times, okay? So when I start, I kept 3 possibilities of spinning. I have a green, I have a pink, and I have a red. And then when I spin it again, I have the choice of a green, pink, or red for each one of these. A green, pink, oh, that didn't come out pink, green, pink, or red. And then I have green, pink, or red. And make that red. So give the sample space. So your sample space would be green, 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 pink, green, red, pink, green, pink, 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 red, red, green, red, pink, and red, red. So how many are that? Is that 1, 2, 3, 4, 5, 6, 7, 8? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that makes sense because 3 times 3 is 9. That's how many possible outcomes we have. Using the sample space or the tree diagram, determine the probability of the outcome landing on green and then red. Okay? Green and then red. Green and then red. There's only one right there. 1 out of a total of 9 outcomes, so that makes it 1 out of 9. What's the probability of spinning exactly 2 pinks? There's only one outcome that has 2 pinks. So again, it's 1/9. Determine the probability of spinning no more than 1 green. Every time I spin, I can either get 0 greens, 1 green, or 2 greens. Is 0 more than 1? No, it's not. 1 is not more than 1, but 2 is. So I have to think of all the possibilities where I have 0 or 1 green, which is actually going to be all of them except for the one where I have 2 greens. So my probability will be 8 out of 9. Okay, the state lottery, number 5. Suppose a state holds a lottery where you buy one out of, no, where 1 out of every 100 people wins per week. If the person is the winner, they have a 90% chance of buying more lottery tickets the following week. Of the people who do not win, they have a 65% chance of not buying another lottery ticket the following week. What's the probability that a randomly selected person won the lottery? So, what's the probability a randomly selected person won the lottery? They tell you right here in the beginning sentence. 1 out of 100. So you can tell me 1 out of 100. If you like decimals better, you can tell me 0.01. Either one. Okay? Create a tree diagram that models the situation. So you play the lottery, and when you play the lottery, you're either going to win or you're going to lose. And if you win, you will either buy more tickets or not buy more tickets. Buy or not buy. And buy, or not buy. Okay, so I'm going to put my percentages on here because I do think it's easier when we have these kind of problems to do so. So here is 0.01, which makes this 0.99. 1 minus 0.01. Now it says if the person has if the person is a winner, they have a 90% chance of buying lottery tickets the next week. So that's going to be 0.9. This will be 0.1. Again, we're subtracting 1 minus 0.9 to get that. Of the people who do not win, they have a 65% chance of not buying. So this would be 0.65 and this would be 0.35 because those two together add up to 1. So to answer the question, what is the probability of not buying more lottery tickets given, okay, and if it's given, it's on here, given that you've already won. So not given that you've already won is up here, and which one of these is not would be the 0.1 or 10%. Again, I'll take either one. That is the probability of not winning, not buying, given that you've won. Okay, using the tree diagram, what is the probability of not having won and buying more tickets? Not having won, to me, from my chart, is losing. So this is the probability of losing and buying more tickets. Now that's an and problem, so I'm actually going to multiply two things together. Okay, losing is 0.99 and buying, once I lose, is 0.35. So when I multiply those together, I get a 0.3465. I put it as a decimal. Okay, yes, you could give me 34.7%. Using the tree diagram, what is the probability of buying more tickets? Probability of buying more tickets and having won. So I should circle. This is the key that tells me to multiply. This one is an and. I need to multiply. So this is the probability of buying and winning. Okay. So we go to winning, which is going to be 0.01 because you got to be on that branch. And buying is 0.9. And 0.01, that's 0.009, which is 0.9%. Okay. What is the probability of buying more tickets? Buying more tickets. So that's this and this together. Have we calculated both of those? We did on these last two. So if I add these two numbers together, then I'm going to have 35.55%. And yes, you could put 35.6%. Okay? Okay, we have to pause. I'll be back. Okay, number 6. Each person in a group of students was identified by year and asked when he or she preferred taking classes in the morning, afternoon, evening. The results are shown in the contingency table. Contingency table, frequency table, same thing. Okay. Find the probability that the student preferred afternoon classes given he or she is a freshman. So again, it will help you receive partial credit, help you see the similarity in all these kinds of problems that you're doing if you will write down this notation. The probability that the student preferred afternoon classes given that he or she was a freshman. And if you think about toppling this over, this is your new denominator now. How many total freshmen did I have? Well, 2 plus 20 plus 9 is 31. So I'm going to have 31 on the bottom. How many of those were wanted afternoon? And that, of course, is 20. And 20 over 31 doesn't reduce, and I don't want to pick up my calculator, so we're going to leave it like that. But again, you can put it in a decimal, carry it out 3 places, or a percent, and unless it's a whole percent, carry it out to the nearest tenth. Okay, find the probability that a student is a sophomore and prefers evening classes. So on this one, sophomore, we're looking for the intersection of sophomore and evening classes. So those two intersect right here, and that's going to be 20 over the total. And so that means we got to go add all these up. So this adds up to 27, 28, and 25. And when I add those all up, I get 111. Now, to make sure you don't mess up, it might be wise to go ahead and add these up. This should be 22, 42, and 47. Okay? So I have and when yes, we multiply most of the time, but if you have a chart, go find that point of intersection, which is 20 over 111. Again, that doesn't reduce, so you're good to go. Okay, find the probability the student is a sophomore. Actually, okay, we've done sophomore SE. Sophomore, given that they prefer evening classes. Again, topple it over, and that means evening classes total is my denominator. That's 47. And how many of those are sophomores is 20. So 20 over 47, again, does not reduce. So we'll put that in the answer blank. No need to pick up the calculator and change it. Okay, this next one says, are the events junior and morning classes independent? Okay, now if they are independent, then the probability of J equals the probability of J given M. Okay, well that didn't come out the way I started. M. Okay, or whichever one of these you think of, that didn't start out either. Probability of M equals the probability of M given J. If these two events are independent, then this J doesn't affect the probability. Okay? So the probability of J is the probability of a junior. How many juniors? I have 28 over 111. The probability of a junior given they like morning classes, so there's my bottom. Morning classes is 22. How many of those are juniors? 14. So you can either cross multiply and see, or change each of these to a decimal, and you'll find out they're not equal. If you chose to do it this way, or this is easier for you to understand, then your numbers would be probability of morning, which is 22 over 111, equals probability of morning given that they're a junior. The total juniors is 28, and how many of those are in the morning is 14. So again, those two numbers are not equal to each other. So are they independent? No, they are not independent. All right, the probability that a dessert sold at a certain cafe contains chocolate is 86%. So the probability of chocolate is 86%. The probability that dessert containing chocolate also contains nuts is 30%. So the probability of chocolate and nuts is 30%. Find the probability that a dessert chosen at random contains nuts given that it contains chocolate. So we know that the probability of chocolate and nuts equals the probability of chocolate times the probability of nuts given that it's chocolate. So you'll see when you plug in the numbers, this is 0.86 equals zero point 0.3. Actually, I got those backwards. This is zero point 0.3 equals 0.86 times the probability of nuts given chocolate. So I'm going to divide by 0.86, and 0.3 divided by 0.86 gives me a decimal of, I'm going to go over here because I don't have enough room. You will on the test. 34837. So let's put 34.9%. A class of 40 students has 11 honor students and 10 athletes. 3 of the honor students are also athletes. 1 student is chosen at random. Find the probability this student is an athlete. So you can start off with the probability of honors is 11 over 40. And the probability of an athlete is 10 over 40. And the probability that he is at honors or athlete and honors is 3 out of 40. Now, is that enough to find the probability the student is an athlete if it is known he is not an honor student? I don't think you have enough information like that, so I would find it easier to draw a Venn diagram with this. So we talked about this earlier, really bad circle, excuse me. So I have my two circles. This is my honors students. These are my athletes. Okay, excuse me. You start with how many are honors and athletes, and that's three of them. I have a total of 11 honors students, so if three are right here, that leaves 8 left to be in that circle. I have a total of 10 athletes, so if I have 3 here, that leaves 7. And so how many students are not honors or athletes? And that would be the rest subtracted, all these numbers subtracted from 40, which would give us 22. So when they're asking me for the probability of an athlete given that he's not honors, okay? So what goes on the bottom is not honors. How many students are not honors students? So hopefully you can see that's everybody except for what's in here. So that's 29. And how many of those out there are athletes? And that's 7. So your answer is 7 over 29. If you want to put that as a decimal, 241,379. So as a percent would be 24.1%. Okay, hopefully these will go by faster. Suppose Q and R are independent events. If they're independent events and you want me to find and, all I do is multiply these two numbers together. So when I multiply them together, I'm going to get 0.3315. And I'm going to leave it like that. I'm not going to take a chance of making a mistake changing it to a percentage. Okay? Probability: two urns contain white balls and yellow balls. First urn has 9 white and 9 yellow. The second urn has 8 white and 3 yellow. A ball is drawn at random from each urn. What is the probability that both balls are white? So we have the probability of a white from the first urn and a white from the second urn. Well, there's my and, so I'm going to multiply the probability of drawing a white from the first urn times the probability of drawing a white from the second urn. From the first urn, I have a total of 18 balls, 9 of which are white, so hopefully y'all see that's 1/2. On the second one, I have 8 white balls out of a total of 11 balls. So that is 2 goes into 8 4 times. That leaves me with 4 over 11. Okay, I didn't need to pick up my calculator, so I'm not going to. All right, moving on. You pick a number between 1,000 and 5,000. Are these two events non-independent or independent? Then you flip a coin. Okay, are they independent? They are independent. Okay, explain, because one does not affect the other. Okay, so if it's words, you just have to explain it that way. Okay, if it's numbers, such as here, how do we prove they're independent? This is what we've been saying. P of A and B has to equal P of A times P of B. I don't have the given part if they're independent. Okay, so P of A and B is 1 over 15. P of A is 4 over 13. And P of B is 1 over 4. Well, my 4's cancel, leaving me with 1/13, but that's not equal to 1/15. That's my justification, and they are not independent. A jar contains 7 blue cubes, 4 blue spheres, 5 green cubes, 6 green spheres. If you select an object at random, what is the probability that your object is green or a cube? Probability green or cube. Okay, or tells me I'm going to add a bunch of things together. Okay, how many total objects do I have? 7 plus 4 is 11, 5 plus 6 is 11, 11, 11 is 22. So I got 22 on the bottom. And how many of them are green or a cube? That's a cube. That's not green or a cube. That's green and a cube. And that's green. So I'm going to add 7 plus 5 plus 6. That's going to be 18 over 22, which simplifies to 9 over 11. All right, a yogurt shop offers 6 different flavors of frozen yogurt and 12 different toppings. How many choices are possible for a single serving of frozen yogurt with a topping? So you have to choose the yogurt and choose the topping. How many choices of yogurt? 6. How many choices of toppings? 12. So 6 times 12 is 72, which brings me to If your answer is more than one, higher than the number one, you should always have a label with it. Okay, these numbers are less than one, they don't have a label. It's greater than one, I have a label with it. Okay, suppose Ruth Ann has 3 routes she can choose from to get to school, the library, and 5 routes from the library to home. How many routes are there from Ruth Ann's school to her home with a stop at the library? So, similarly, we have 2 choices. We have 3 routes from school to the library. We have 5 routes from library to home. So how many different routes are possible? 15 routes. Again, numbers larger than 1. I'm going to see if I can move this over because to do this problem below it. Come here. Move over. Okay, you go with it. There you go. All right. So the next one, these problems. When you see these problems on there, you must show me how that is done. You may check it with your calculator, but you have to have work on your paper that supports your answer. So 9p4 means 9 factorial over 9 minus 4 factorial. And that means you can do 9 times 8 times 7 times 6. And you can, the last number you have to write here is whatever number you have on the bottom. 5 factorial. And those cancel. So you're going to multiply 9 times 8 times 7 times 6 with your calculator, and you're going to get 3024. All right, if it's C, then you do still the same thing, 7 factorial over 7 minus 6 factorial, but then you have to put the R factorial again because you're dividing out by those repeats. So 7, and when you have 2 factorials on the bottom, I didn't mean to do that, oops. When you have 2 factorials on the bottom and you're listing the factors on the top, stop with the factors once you get to the bigger factorial on the bottom. 1 factorial is 1 times 6 factorial. Those cancel, so you're left with just 7. Okay? How many different orders we're getting there, y'all? We're getting so close. How many different orders can you line up 8 cards on a table? 8 cards means I have 8 slots, and 8, 7, 6, 5, 4, 3, 2, 1 is the same thing as 8 factorial. And 8 factorial is 40,320. It's more than one. I need a label. How many different orders? So I'm going to write orders. Okay. How many ways can 12 basketball players be listed in a program? Is it a different way to list it if I change the order? Absolutely. So again, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, or 12 factorial. 12 factorial is a really large number. 4, 7, 9, 0, 0, 1, 6, 0, 0 ways. All right. There are 10 students participating in spelling bee. How many ways can the student who goes first and second be chosen? So the only people that get something are first and second. So you can say I've got 10 choices here and 9 choices here. Or you can think of that as 10p2. And that will still give you, you'll end up with the same thing. Put it in your calculator and you'll find out 90. Bigger than 1, I need a label. That label is ways. How many ways? 90 ways. It just helps you make sure you answer the question. Vern has 6 math books to line up on a shelf. Jenny has 4 English books to line up on a shelf. How many more ways can Vern line up his books than Jenny? Okay, so we've talked about lining up on a shelf. The order matters. Okay, how many ways can he list it up? It's very similar to these problems. So basically what we're doing is 6 factorial minus 4 factorial. Again, use the button on your calculator. Okay, you've already shown me you know how to do it. 6 factorial is 720. 4 factorial is 24. And 720 minus 24 is 696. That answer is larger than 1, so I need a label. How many more orders? 696 more orders. Okay, so the Booster Club sells meals at basketball games. Each meal comes with a choice of hamburgers, pizza, hot dogs, cheeseburger, or tacos. and a choice of root beer, lemonade, milk, coffee, tea, or cola. How many possible meal combinations? So you're going to have a an entree basically, and you're going to have a drink. So you only have two choices. How many choices for your entree? Hamburgers, pizza, hot dogs, cheeseburgers, or tacos. That's five choices. Root beer, lemonade, milk, coffee, tea, or cola. That is six choices. So when I multiply together, then I have 30 possible meal combinations or meals is fine. Okay. All right. How many ways can three singers be selected from five who come to an audition? Those three singers don't have specific positions, so the order that you choose them does not matter. So this is 5C3, and that is going to be 10. If you have any trouble with your calculator, come see me before school. Okay? There are 8 people on the ballot for regional judges. Voters can vote for any 4. Voters can choose to vote for 0, 1, 2, 3, or 4 judges. How many ways can a person vote? So you're choosing from 8 every time, but you can 8 choose 0, or you can 8 choose 1, or you can choose 2 from the 8, or you can choose 3 from the 8, or you can choose 4 from the 8. So that's how many different ways you choose them. The order I vote for the judges doesn't matter. It's not a different 2 judges or okay. And then you have to add up all those possibilities together. So you would punch your button each of these. 8C1 is 8C0 is 1, 8C1 is 8, 8C2 is 28, 8C3 is 56, and 8C4 is 70. And when you add all those together, you get 163. That's numbers larger than 1. I need to put a label on my answer, 163 ways. All right. Oh, there's the end. A bag contains 6 red marbles, 6 white marbles, 4 blue marbles. Find the probability of red or blue. Okay, how many marbles in my bag? 6 plus 6 is 12 plus 4 is 16. And how many of them are red or blue? 6 plus 4 is, I'll write it like that, 6 plus 4. So we have 10 out of 16, which becomes 5 out of 8. Okay? Um, Same problem. This time it says and, so I'm doing probability of red and blue. Okay? Again, how many marbles? 16. I'm only drawing one marble, y'all. It doesn't tell me I'm drawing two marbles. How many of these marbles are red and blue? None of them are. So the answer here is 0. Okay. A spinner is numbered from 1 to 10 with each number equally likely to occur. What is the probability of obtaining a number less than 2 or greater than 7? So what numbers are less than 2? Between 1 and 10 is only 1. What numbers are greater than 7? 8, 9, and 10. So how many of those do I have? I have a total of 4 numbers out of 10 possibilities. So 4 out of 10 is going to be 2 out of 5. Does that look like a 5? I don't think so. 2 out of 5. There we go. All right, 2 more. Tisha's in the French club. There are 21 students in the club. The French teacher will pick 2 students at random to guide visiting students from France. What's the probability that Tisha will not be picked as a guide? Okay, so the teacher is picking 2 students, so she has 2 choices to make. So if you want to think of that, okay, she has 2 choices to make. The probability that she chooses Tisha, but they want the probability she's not chosen. So how many students are not Tisha? Well, I think y'all know that's 20 out of a total of 21 students. And then once she picks one, how many are left is 19. And she's already picked one, so there's only 20 because there's only 19 that aren't Tisha. My 20s cancel, leaving me with 19 over 21. All right, last problem. What's the probability of being dealt exactly 3 fours in a 5-card hand deck from a standard 52 card deck? This is like the shark problem, the last problem we had on lesson 4. Really like this problem because it lets you know how ridiculous sometimes it is to play poker. Just kidding. Anyway, 3 cards. 3, you're going to draw, you need exactly 3 fours. So there's only 4 fours in a deck, and I need 3 of them. It's combinations because the order I get them in does not matter. Alright, I only have 3 cards. I still need 2 more cards. How many cards are left from the deck to choose from? There are, and how many cards in a deck? There are 52 cards in a deck, and for a 5-card hand, so 52 choose 5 is how many possible 5-card hands. I need 3 fours, and that means that there are 48 cards left, and I need 2 of them. Okay, so if you notice, these 2 numbers give you that one, and those 2 numbers give you that one when you add them together. So, punch your calculator, okay, and it might help to show me this work so that if you make a mistake, okay, I can follow your work. 4 times 1128, that's 4C3, 48C2, and then 52C5 is 2598960. Okay, as a reduced fraction, that is 94, and that is not what I wrote. I wrote 49. 94 over 54145, which as a decimal is 0.001736. And since most of our answers have been decimals, I'll put it in percent. Let me put it in percent. So I move it over 2 places, and that would be 0.2%. So that's the percent that you have of getting exactly 3 fours when you are dealt a 5-card hand from a deck of cards. So I hope that helps you prepare for your test. Please email me or come see me if you have any questions about any problems on here or if you have problems with your calculator. Thank you very much. We'll see you soon.